I'm going to start off by doing a smoke simulation, which will be used to drive our particles. So first I want to come in our viewport and change the background color to dark. And I also changed this frame range to 96 from 240. For the smoke source, I'm going to use a sphere. Just call this FX, and this is where all of our effects are going to be. Set this to a polygon sphere with a frequency of 10, and I set the radius to 1 by 1 by 1. I'm going to use a pyro source node. Set this to volume scatter and do a source smoke. I also want to give these points an initial velocity that we're going to use to drive our smoke. So let's do that using the adjust attribute adjust vector node. And as you can see, this is already set to velocity. Let's use a noise and a zero center noise. Make the amplitude 2, and I set the element size to 0.05, and I also turned on this animate noise. So if I press here, I can visualize our velocities, and if I press play, you can see we now have velocity vectors moving around. To turn this into a volume, I will use the volume rasterize attributes node, and I'm going to set this to density, temperature, and velocity. And I want this voxel size parameter here to be linked to our particle separation. So I'm going to copy this and do a paste relative references here. And the value I ended up using was 0.05. I also want to press this normalize by clamped coverage, remove the density, and create a new attribute rule, which I'm going to put velocity. Let's do a null. Call this smoke source. And this is all we need to do our smoke simulation. I'm not going to be talking in detail about pyrosims in Houdini in this video, but I will show you the values I ended up using for this project. So let's create a DOP network and call this smoke sim. And I can plug this into the first input. So let's dive inside. We need a volume source. We need a sparse smoke object. And the pyro solver, I'm just going to copy from my original file and show you the settings. So it's this here. So let's plug this smoke object into the first input and the volume source into the third input. And for the volume source, I'm just going to select first context geometry and press enlarge fields to contain sources. And I want to choose something else and then go back to source smoke, and then it's going to work. So what I ended up doing was, for this temperature, I actually changed this to pull, and I set the acceleration strength to 50 and the deceleration strength to 0. In addition to this, in my smoke object, again, I want this voxel size to be consistent across all my nodes. So I'm going to copy parameter, go up one level, and do a paste relative reference in my rasterize attributes node. Again, I'm going to set this to 0.05. And in this creation tab, I am going to check solve on creation frame. And the reason I do this is because on frame 1, if I don't have this checked, then we have nothing coming in. So I always check this. For the pyro solver settings, I'm going to quickly show you. I checked this speed field. I set advection reflection to single project and the buoyancy scale to 0. In the shape tab, I set dissipation to 0.15, disturbance to 15, and turbulence to 0.25. In the dissipation tab, I checked this control field and just left it at default settings. And in the disturbance tab, I also checked control field and I put in speed with a value of 0.25. I also changed the block size from 0.2 to 1. And in the turbulence tab, I set the swirl size to 2. The influence range I changed to 0.1, and yeah, that's it. And in the advanced tab, I set this resizing tab to have a padding of 1, and the advection scheme I ended up using was PFECC and clamp. So let's play this and see what we get. And this is good enough, honestly. So I'm going to go up one level and let's cache this to disk. So in order to cache this result to disk, we have to bring this data from DOPS into subs. And just a quick tip, if you want to visualize the result of your sim without using any other nodes, you can actually just put density here in this data field and your smoke sim is going to be visible. But we are actually going to use the DOP import fields node for this. And this DOP-net, I'm going to drag it into the DOP network. And in this DOP node, we have to actually go inside the DOP and copy the path of our smoke object. So I'm just going to do Control-C, go back up and paste it here. And let's choose smoke in the preset. And you can see we have brought our smoke sim. The only fields I need for this is, actually I only need velocity, but I'm going to bring density as well, just so we can see our smoke. And in order to save disk space when caching smoke in general, it's always good to use the pyro post process node. And I'm going to check convert to VDB, combine volumes, and as well convert to 16-bit float. Let's cache this to disk with a file cache node. And I'm actually going to cache more 1 second longer than our frame range because I want to time shift this after. So let's come in here and do a right click and delete channels. And let's just do plus 24. So this way we have 120 frames we're going to be caching. You can just press save to disk and let this run. And now that my cache is finished, you can see we have a good looking smoke sim. I'm going to actually offset this, use a time shift node and this expression here. Let's just do a plus 12 to start off and see what that looks like. And the reason I'm doing this is because I want the smoke simulation to already have evolved to a certain point when I use it to advect the particles so they don't start at the same time. And that's all we need. So let's do a null again. Say velocity field. And we're now ready to sim our particles. Let's begin working on our main effect, which is going to be this particle simulation. So I'm just going to take our original sphere and copy it, paste it down here. And let's make this a little bit smaller. And I want to turn this into a volume with a VDB from polygons node. Fog VDB. Let's up the resolution, and I'm going to scatter points inside of this to get a point cloud. Turn off relax iterations, and let's set this to something like 20,000 to begin. I'm also going to come in my viewport and right click this icon here and visualize points as pixels. And I want to noise this source up a bit. Let's create a point up and do a vector to vector 4 and feed this into an anti-aliased flow noise. Let's make this our color and hit play. So I think our shapes are a little bit too big. So I'm going to up the frequency to 2.5, 2.5, 2.5. And the time frequency, I'm going to make this 1.5. And if we want to bring these dark values a little bit, shift them towards the brighter colors, we can use a fit range node and just make this 0 a slight negative number, 0.5. You can see we have shifted our colors a bit. And I'm going to a blast node and delete all of our darker points. So at cd.x less than 0.05 and make this points, and we can see we now have 8,830 points, and before we had 20,000 points. So this is just to make our source a bit more interesting. And I want to just give these points a rest attribute, so we can use this to color our particles later. And let's create a null. And this is going to be our particle source. So for this particle simulation, it's not going to be anything fancy. Just do a pop network, feed our source into the first input, dive inside, and let's change this to all points, and the life expectancy to 1 second with a variance of 0.25. Let's delete this merge node. And I want to bring our smoke's velocity field into this simulation using a add_vect by volumes node. And this workflow where we have a smoke simulation and add_vect particles through the velocity field is the most common way to create magic in general. So that's what we're going to be doing. And let's set this to update velocity and trace midpoint. And we have to find our velocity field, the null we created. Hit accept, and let's see what we have. And this is good. The only thing I think we should do is add some drag to this just to tame the velocities. So let's set this to a low number like 0.15 and go up. Yeah, this is good. And I want to show you a trick to get a more magical look with these particles. So what we often look for in magic in general is we want this kind of wispy, stringy movement, which often is a result of particles clumping together. And this is really easy to do if we just use a flip simulation, but it's a little bit more tricky to do when we just have this regular pop sim. So we can actually do this with a node called attribute blur. I'm going to uncheck pin border points and set this to proximity. Just up the neighbors a bit and set this to 2 iterations. And we can already see we have much more of this particle clumping that I was mentioning. So before and after, and this is already looking much better. And if we want to, we can actually do this on our source points as well. So just to make them a little bit more clumped together. And this is a really good technique to get more of that magical type of look. So let's see what we have. I think this is going to work really good. Maybe let's just change this one to 1 iteration to make it faster. And in order to color these points, I am going to use the attribute adjust color node. And let's use a noise. And we're going to use the rest attribute that we created on our source. So let's set this to rest. Set this to a grayscale just to begin. I think the element size is a little bit too big, so let's make it 0.5. And here you can just choose some colors that you like. I'm just going to choose some blue colors. And you can go crazy with this. You can mix different colors and you can change this noise type just to get different results. So just experiment a bit here and find something you like. I'm just going to stick with the blue and the black colors, and let's make this animated with the pulse duration of 3, and I'm going to set this to Perlin flow. And in order to make this a little bit more interesting, I can actually use a point up, and I can make our colors change based on the particle's age. So let's take the age and the life and divide them. I'm going to use a ramp, make this a spline ramp, and call this age CDs. And I want to multiply our already existing colors with this ramp. So let's do a multiply. And let's go up 1 level. Going to flip this ramp. So this way the particles will start off their original colors and slowly fade to black as they age. But I actually want to make kind of this glowing core type of effect here. So let's expand this ramp. And I like to use B-spline. Just select both of these ticks and set them to B-spline. And I'm actually going to make this starting value higher than 1. Let's set it to 3. And we can adjust the ramp bit, just to make this glowing core fall off a bit faster. And I also want the particles to start off black. In this way we can just hide some potential banding or artifacts that might come from our particle sim. So now we have this. And we also want to make sure that this color value has a value on each axis. Just make sure that none of these numbers are ever 0, because when we multiply the colors in the shader, if it's 0, it's still going to be 0 even if you multiply it with 100. So we want to have that kind of additive look. So this is very important to make sure you have some values in all axes. And just for later, we also want to, for rendering, we need the p-scale attribute for our point particle sizes. So let's create that with a bind export node. And I'm just going to make this a parameter. And set this, call this particle scales. Let's just set this to 0.05. And if we want motion blur to work properly when we are rendering this, we actually have to recompute the velocities, because we have manipulated the particle positions with this attribute blur. So let's just put down a trail node at the end. Set this to compute velocity and central difference. And we have to check this match by attribute. And that's all we need to start rendering. Let's call this particles and start shading these particles. So before we start shading, I want to just create a camera and frame them in a way I like. So I'm going to control click this camera when I have something I like. Control click. And I'm going to zoom out a bit and make this focal length something higher, like 75. Zoom out. Something like this would be okay. And turn off this lock. And I'm going to be showing you how to render this in Redshift, but I'm also going to have a bonus section in this video about how we can shade these particles in the same way using Mantra. So let's go to the material context, do a RS material builder. Call this material particles. Just going to copy this and assign it to our particles. Let's go back to materials and just delete this and create a RS material. So what I want for this shader is just something without any diffuse, any reflection, and I just want emission. So let's set this emission weight to 1, and I want the emission color to be the particle color that we have just created. So let's do a point attribute, RS point attribute, and this is already set to color by default, CD. Let's plug this into emission color, and in our out context, let's just create a Redshift drop and see what this looks like. One thing I forgot to do is we have to specifically tell Redshift that these are particles. So come into your node, and I just pause the render and go to this Redshift object here and go to particles and hit render object as particles, and we can re-render this. And we have our particles showing up. Okay, one thing, we do not have motion blur, so let's come into the Redshift drop and go to advanced motion blur and enable instances particles blur. And if we update our render, we can see this is now working. And we want to adjust our points opacity so we can actually see through and have that additive look when the particles are clumping together. So let's come in our shader again and adjust this opacity to something lower, like 0.1, and increase the emission. And we can see we already are starting to get this type of magical look. And this is how I would shade magic in Redshift in general. The only thing we're missing now is we need way more particles, and the particles are too big. So I'm going to be showing you my final render setup for this. Let's take a look at the final render setup. that I ended up using, and I'm going to be providing this file in the video description, so you can take a look at that if anything is unclear. I didn't change anything about the smoke sim, so it's exactly the same setup that we did together. I changed the sphere to have a frequency of 10, and the point count of the scatter node was set to 1,125,000. I also changed our noise a bit to have a time frequency of 2, and the source min was set to -0.1. I also adjusted this attribute blur slight bit to 6 iterations with 150 max neighbors. In addition to this, I changed the point drag to be 0.1, and everything else is the same. And then after the sim, I cached my particles to disk. I ended up caching 17.5 million points, which is a good amount. And we need this high point count if we want to have that smooth look. But before caching, I did an attribute delete and deleted ID, age, life, and rest. I also deleted any groups. And this is just to save disk space because the particle simulation will give you so many unnecessary attributes. So I just went and deleted the ones I didn't need. This attribute blur is also just the same. And the colors, I changed a slight bit. Again, you can check the files for to have a more detailed look. I also changed this ramp a slight bit, and the final P scale I ended up using was 0.0055. And if I dive inside, I took the ramp that we used to multiply our colors, and I clamped it, and then I multiplied our P scale with this ramp, just so the particles will get smaller as they die off. And again, this trail is just the same. Then I have a setup for the geolight, which is just turning them into an SDF, then smoothing it out. Then I converted them to polygons again, and that is being fed into this Redshift mesh light, which has the same color as our particles assigned. I also just have a separate object for the geometry. I also adjusted our camera a bit. You can see these are the settings. And for the environment, this is just a grid with some subdivides, and then I made some UVs. I can show you. Made some UVs with this UV unwrap node. Then I just assigned a texture to this grid, which is just a free texture I got from Polyhaven. And I can show you the shader for this. So I fed the color map into diffuse color, the roughness map into diffuse roughness, and reflection roughness, and the bump map is being used into this bump input. Then I have a displacement map. This should be set to raw, which is the height map of the shader, which is also being fed into this. And if you want to have displacement work with Redshift, you have to come into this Redshift object here and enable displacement down here. Let's take a look at the render settings. For the particle renders settings, I ended up rendering the environment and the particles separately. But the particles is the camera resolution just multiplied by 1.5, just so we have a little bit more resolution to work with in comp. And the rest of the settings are pretty much the same, except I changed this threshold to 0.0075, and everything else is just the same. And then I ended up rendering out 96 frames, and I'm going to be showing you how we can comp this together with the environment inside of Nuke. So let's take a look at that. Let's try to comp this project together in Nuke. I'm going to press R, and I'm going to navigate to the frames we have rendered out from Redshift, and let's open our particles. Press 1 to visualize this, and we can press space in this viewport just to have a look at our raw render. And the first thing I am noticing is that our color space in Nuke is not set to the right setting. So I'm going to press S in this area. Let's come into the color settings and change this from Nuke to OCIO. And this is looking more promising. And you can see, because of that attribute blur and because we have so many particles, we have lots of this type of stringy behavior that I was mentioning, where the particles are clumping together, and this is a very magical look overall. So what I would do first is let's just denoise this render a bit. So I'm going to create a denoise, and for this to work, we have this section. So I'll just move this over to our particles, and if I highlight this node and press D, I can disable it so we can view our before and after, and this is with the denoise. And this is without the denoise, so we can see how much more smooth this is. Seeing that this might be a little bit too blurry, so I'm just going to do a sharpen node just to bring back a bit more details. And if you wanted to blur this even more, if you feel like your result isn't smooth enough, you could use the motion blur node in Nuke. So let's try that. You can see this already blurs this by quite a bit. So this might be too much. So we can adjust this shutter time parameter to something like 0.5 and shutter samples to 12. And this is looking a little bit better. Maybe it's still too much. So I'm just going to set this to a lower number, and that should be good. I also think the sharpen is a bit too strong. So let's reduce it. Yes, this is looking better. And I think this whole render is a bit too saturated. So I'm going to press C to create a color correct node. Just desaturate this a slight bit, something like this. And we can also increase the contrast a bit. Something like this might look nice. And I want to just isolate these highlights a bit and modify them individually. So I'm going to create a keyer node. And what this node does is, if we press 1 to show this and press A in our viewport, this gives us an alpha channel based on the luminosity of our picture. So I can adjust this just to isolate these very bright areas. And this can be used as a mask for other nodes. So let's create another color correct with the C key and plug this into the mask input. Going to press 1, 2, and A again to disable the alpha viewing. Let's just desaturate this just in these highlights here, and we can maybe gain it up a slight bit. We can already see this is looking much better. This is what we started with, and this is what we have. Now, before we do anything else, I would like to bring our environment and just see how this is all going to be working together. So let's press R and navigate to where we save the environment. And let's press M and merge these two together. So let's merge this with this and view this. First of all, the inputs are flipped. So I'm going to press Shift X just to flip this. And I can already see that since I rendered this environment at 1920 by 1080 and the particles were rendered at a higher resolution, we have to reformat the particles to match our environment. So we have to change the project settings for this. So let's press S, come into the root settings, and just change this full size format here to 1080. And I'm going to use a reformat node after the motion blur, and you can see everything is matching. So let's try to add some glows to this. There is a glow gizmo that I really like called AP Glow, and you can download this from Nukepedia. going to plug it into our color correct. Let's just view this. This is looking okay. Let's create a merge node with the M key again and merge it together with our particles. And set this to plus. And we can see we have some glow. I think the glow is a little bit too small. Let's change the size fall off, make it a bit bigger. Oops. Something like this. And we can increase the persistence a bit. And set this to 2.5 perhaps. And decrease the intensity. We can see we have something coming together. You can also adjust this source white. And the glow is a little bit too much. And this is about it. I think this is looking quite nice at this point. So let's start working on the environment. Press 1. No, we can actually visualize everything. And let's do a color correct node with the C key. And I just want to desaturate this a slight bit. And we can change the tone a bit to match the particle colors. So let's come to this gamma color wheel and control click this color wheel. And I just want to remove a little bit of the green tones. So let's come into this here and do something small just to remove the green tones a slight bit. Yeah, something like this. It's looking nice. And if I want to, I can also add a glow to the environment, and it might help tie this all a bit more together. So let's uncheck this effect only parameter. And this is way too much, so let's set it to something lower. You can see this helps slightly with just bringing everything together. Another thing we can do to bring this a bit more together towards the end is add some chromatic aberration. This is another gizmo I like to use called FXT, chromatic aberration. I'm going to be linking all of these in the YouTube description. So let's connect this here. Let's see what we have. We can see that this is just giving us this slight kind of red artifacts on some of our pixels. But I want this to be universally affecting our scene and not just towards the end. So let's uncheck this use center mask thing. And let's see if we can see anything. Maybe it's slightly noticeable. We can up this scale a bit. Yeah, we can see it here. So this might be a bit too much. Let's do 0.4004. And this also helps just bring everything a bit more together. We can also add some lens distortion. It's a very low number. You can see it kind of pulls our edges a bit, which also helps. And to finish this off, I would just add some grain. See, we get this kind of filmic grain look. But this is at the moment based on our alpha. And if we look at our alpha channel, we can see that this is not good. Let's press A again and let's create a new alpha channel using this keyer that we did before and plug it in before the grain. And now we can see the grain is more universally applied, but it might be a little bit too much. So I'm going to adjust these intensity parameters. And in Houdini, we have this concept of relative references, and we have this in Nuke as well. So let's come into copy and do copy links. And I'm going to come into the green parameter and do paste relative. So they're always linked. And let's do this for the blue color as well. Actually, I would like to do the blue one separately. So let's just adjust this a bit lower. And I'll leave this like it is. I just want a very, very slight amount of grain. This is looking nice. And let's add some vignetting just to finish this off. This is another gizmo I'm using called AP Vignette. And it just gives us some dark artifacts on the side. And this is too much. Let's set this to 0.35. And we can see that's just slightly darkens our edges. And let's play this back and see what we have. I'm going to press space in the viewport just to full screen this, and then press H and play this. So this is what I came up with. I think this is working quite well. The only issue I would say is that we have, I think our highlights are a little bit too overexposed, but you guys can go and adjust the gain and bring it down a bit, and maybe mess around with the glows just to see if you can get a better look. And I just want to show you for one last thing, just how I would go about just changing the color of this if I wanted to. What we can actually use is let's just move this a bit down. We can use a hue shift node. And if I adjust this hue rotation, we can see our colors are slightly changing. And obviously this is looking a bit crazy. So you would have to adjust the saturation and the brightness settings to get something that looks good. But you could basically make this any color you'd like. You could make this like a fell magic type of look. Which again, you guys could experiment with this. So this is the final look, and I hope you enjoyed the tutorial. Thank you for watching. Just do a principled shader, call this mantra particles. Again, I don't need any albedo or roughness or reflections, and I'm just going to set this emission intensity to something like 10, and let's assign this to our object. And I also want to go into sampling and turn on this velocity blur. In the out context, we can create a mantra node and set this to allow motion blur, and we could up the samples a bit. And I'm just going to enable our particles and turn off every light, and we can see what this looks like. So we can see that this is way too bright. So let's go back into our shader and turn down the emission, something like 1, and check this use point color. And if we want to get this additive look, we can go into our opacity and just set this to something really low. And by doing this, we have basically replicated our Redshift shader look. You would obviously have to go and adjust the sampling settings to get a better result, but this is how I would shade this in Mantra.